In this video, we will talk about consistent hashing. First, let's understand what is a hash. A hash function is a function that maps one kind of data, typically describing some kind of object, often of arbitrary size, to another piece of data, typically an integer, which is known as hash code or simply a hash. Using this hash, we can map our data to some kind of hash table or map for easy retrieval. A good hash function generally has a wide output range, typically the whole range of a 32 or 64-bit integer. So building an array for all possible indices would be impossible and a huge waste of memory. To overcome that, we can have reasonable sized array, let's say just twice the number of elements which we expect to store. And we can perform modulo on the hash to get the array index. So our index would be hash of our input modulo the size of your array. In this case, we have size of array as 10. So we will be doing hash modulo 10 in this case to get the array index. So in this case, the hello would map to index 3, word would map to index 7, and consistent would map to index 5. Hashing has different types, and collisions can also occur for a given hash function where more than one input is mapping to a given index, but we will not deep dive into details for this video. In some situations, it may be necessary or desirable to split a hash table into several parts hosted by different servers. One of the main motivation behind this is scalability. Check description for link to my video on scalability. So we need scalability because one server cannot handle all the load. When we split our hash table, in such a scenario, the objects and their keys are distributed among several servers. Such setup usually consists of caching servers that host many key value pairs, and they are used to provide fast access to data which is originally stored somewhere else. For example, to reduce load on database servers, we can design our applications to firstly query the cache servers. Only if the data is not there on cache server, which we refer to as cache miss, then we contact the database server, run the query, and then cache those results on the caching server, so that the next time we need the same data, we can do a faster lookup. So how does the distribution take place? How do we determine which keys are hosted on which server? The simplest way is to use modulo operation. So we compute the hash of data and then take modulo with the number of servers. So here we have 3 servers, so we'll take modulo with 3. To store or retrieve a key, the client firstly computes the hash, then applies the modulo with the number of servers to get a value. This value can act as an index which we can use to determine which server to contact. In this case, 0 index refers to server A, 1 index refers to server B, and 2 index refers to server C. So based on this, hello and hashing will reside on server A, word and distributed will reside on server B, and consistent will reside on server C. We have to use hash functions which map our data in such a way so that outputs are spread as evenly as possible over the output range, so that we have some even distribution of data over multiple servers. So what happens if we want to add one more server? So in that case, we will have to compute modulo with n equal to 4. So let's do that calculation. So here is the modulo with 3 when we had 3 servers. Here is the modulo with 4 when we added one more server. So do we notice any problem here? Yes, we have a problem here. When we increase the number of servers, almost all of our keys are getting mapped to a different index, which means they need to be redistributed to some other server. In this case, only index for one of our keys is same, otherwise all the other indexes got changed. So changing the number of servers requires us to redistribute almost all of our keys. This is true for any distribution scheme, but the problem with our simple modulo distribution is that when the number of servers change, most hashes modulo n will change. So most of our keys will have to be moved to a different server. So even if in this case we only changed one server, all keys will likely need to be rehashed to a different server. So as in the typical use case, as we discussed, we were using these as caching servers. This means all of a sudden your keys won't be found. The percentage of cache miss will be high in that case. So it will, most of your queries will result in misses, and original data will likely need retrieval again from the database, and then those will be rehashed to different caching servers. This way we are placing heavy load on our database servers. This will degrade the performance to a large extent, and it may even crash our database servers. So now we need a distribution scheme which does not directly depend on number of servers, so that whenever we are adding or removing any servers, the number of keys that need to be relocated is minimized. And once a scheme is consistent hashing. So now we understand the problem and what we are trying to solve. Now let's understand how consistent hashing solves this problem. Consistent hashing is a distributed hashing scheme that operates independently of the number of servers or objects in a distributed hash table. We refer it to as distributed hashing scheme because our keys are spread over multiple servers in this case. Consistent hashing allows servers and objects to scale without affecting the overall system. Now let's understand. Consider that we have a hash function whose output range is from 0 to 10,000. Imagine we mapped this output range onto the edge of a circle. So what we could do is we take our data, compute its hash, and then find out where it lies on this circle. Similar to objects, imagine we placed our servers also on the same circle. To compute the server key, a convenient way is to hash the server name or IP address or some kind of unique ID which each server has. Now let's understand how we place our objects onto the circle. In the first column we have our keys, and in the second column we have their computed hash. Considering this is the 0 value, so this is how our values will be distributed onto the edge of the circle. Now for placing servers on the same circle, first column is our server IP, and this is the computed hash for each of the server. So here is server A, here is server B, and here is our server C. Now how do we decide which of the keys will lie on which server? A simple rule which we can use here is to move in clockwise direction until we find a server. So we kind of try to locate the closest server to a given key on the circle. So that way consistent and hello would be located on server A, hashing on server B, and word and distributed would go to server C. From a programming perspective, what we would do is to keep a sorted list of server values so that whenever we have an object key, we can do a binary search to find out a server whose value is greater than or equal to the desired key. If no such value is found, then we can simply take the first server from the list. So, what is the benefit of this circle approach? Now let's consider, let's say we remove the server B. So what happens in that case to the keys which were located on the server B? So simply in this case, for this key, we just need to find the next closest server. So this will be redistributed to server C. Whenever we remove a server, it would lead to the keys which were assigned to that server. Those would be redistributed to other servers on the circle. What happens to the other object keys? The keys that belong to server A or server C? Nothing, right? That's the beauty of it. The removal of server B does not affect those other keys in any way. So removing a server results in its object keys being reassigned to some other server, leaving all other keys untouched. That's why it is independent of the number of servers and object keys on the distributed hash table. Something similar happens. So if we, instead of removing server B, we add one more server here. So let's say we wanted to add server D. In this case, only one key would need to be reassigned to server D. Rest of the keys would remain as it is. So this way we are minimizing the number of keys which need to be redistributed whenever we change number of server in our network. To ensure that object keys are evenly distributed among different servers, we need to apply a simple trick. Rather than assigning only one position to a server on the circle, we would assign it multiple positions. So each server will have multiple values and it would be found on multiple locations on this hash string. Let's say for server A, we have server A1, server A2, server A3. All these three represent the server A. Similarly, for server B, we have server B1 and server B2 labels. And for server C, we have server C1, server C2, and server C3 labels. How many labels to assign to a given server depends on the weight we assign to that specific server based on its capacity, power, storage. All these factors come into picture in that case. So let's say if server A is twice as powerful as server B, then we would assign it to twice the number of labels which we assign to server B. So in this case, let's say there is some key here and then there is another key here. Both would go to the server A. That way, we are trying to evenly distribute our keys among different servers to avoid overloading any one server with too many keys or storing too few keys on a given server. In general, only k divided by n keys need to be remapped, where k is the total number of keys and n is the maximum of initial and final number of servers we have. So this is how consistent hashing solves the rehashing problem when number of server changes. So we have observed that whenever we are using distributed caching to optimize the performance, it may happen that number of caching servers may change over time. So this could be due to servers crashing or a need to remove or add servers based on the traffic we are observing, or we may want to increase or decrease the overall capacity of our system. So by using consistent hashing, we can be assured that whenever we change number of servers, the number of keys which we have to rehash is minimized. That way we can prevent potential downtime or performance issues. That's all for this video. Hope you have learned something useful. Thank you.